Here we are in the collections area, the Royal Tyrrell Museum of Paleontology. And the bone room is a great place for us to see how soft anatomy in dinosaurs is interpreted. Like skin and integumentary structures, we have evidence of other soft tissue preservation. So for example, in a coprolite, or dinosaur dropping that was found in Dinosaur Provincial Park from a tyrannosaur, we have the remains of muscle fibers. There's a magnificently well-preserved dinosaur from Italy, which includes the cartilaginous tracheal rings still preserved in the throat and muscle fibers at the base of the tail. However, our best evidence for soft anatomy comes from looking at the bones themselves. So for example, if we look at this upper arm bone from a Tyrannosaurus rex, it's not very big, even though this animal weighed about 8 tons. This bone had very powerful muscles attached to it. And we can see these striations where the muscles attached to the bone itself. And in some areas, there are very large scars on the bone, which is where the muscles attached. And we can see that those were powerful muscles for manipulating the arm. Leg bones are very similar in that there are muscle scars everywhere in the leg bones. And in this case, we're looking at a femur, or upper leg bone, from another tyrannosaur. You can see the head of the femur here, and near it, there's a very large crest. And this crest behaved like a lever. The muscles attached to this, and they helped move the leg in very powerful forward motion, in this case, for this dinosaur. Now, we understand what muscles attach to where in these bones because we have living representatives of the dinosaurs in both birds and crocodiles. Birds are the descendants of dinosaurs. Crocodiles are the second cousins of dinosaurs. And if we find that the same muscles attach to the same points on the same bones in both birds and crocodiles, we can infer that those were the same muscles that attached to those points in these dinosaurs. Although muscle attachment points are conservative in living vertebrates, their positions and capabilities can vary because their lines of action change as the shapes, proportions, and orientations of the bones are modified in different groups of vertebrates. The jaw muscles of tyrannosaurs, for example, are relatively short and broad and attached to the lower jaw in a way to maximize the power of the bite. Tyrannosaurs were capable of biting right through the bones of their prey. This Triceratops ilium and hip basically provides a graphic example showing how strong the jaws of Tyrannosaurus rex were. These jagged breaks here were caused when the teeth and jaws of Tyrannosaurus bit right through the bone and took that part of the bone away. These holes are places where the jaws drove the teeth into the bone, but they didn't break the bone, they pulled the teeth out again. This particular tooth hole is so deep that if you pour rubber into it and pull out the rubber after it's dried, you get a perfect replica of a Tyrannosaurus rex tooth. Stanford University did a series of experiments with this specimen, and they were able to show that the amount of power that had to be generated to do this much damage to this bone clearly showed that Tyrannosaurus rex had the strongest bite of any animal, living or dead. This is the jaw of Tyrannosaurus rex, and this is the jaw of another gigantic predator known as Giganotosaurus. Giganotosaurus had a much longer skull and lower jaw than those of Tyrannosaurus rex. That's because the back of the skull had extended further backwards so that the jaw muscles, which attach right here, could be quite a bit longer than those of T-Rex. The longer jaw muscles meant that it did not have as powerful a bite as Tyrannosaurus rex, but it could close its jaws much faster.
Well, we've covered a lot of material in this module on appearances and anatomy. You've learned about dinosaur sizes, bone arrangement, the main dinosaur families, integumentary structures, colors, and muscles. Everything we've learned so far has its origins in the study of fossilized dinosaur remains. But what is fossilization? Where do these fossils come from? How are they excavated and prepared? Well, these are some of the questions we'll be looking into in the next lesson. See you there.